Alright, quadratic facts number 2. We are going to cover the y-intercept. We are going to cover forms of the different types of quadratic equations, minimum and maximum values, and what is a zero. So, first question is, 1. How can I find a y-intercept? In standard form, this is nice and easy. For f of x is equal to ax squared plus bx plus c, which is where we do a lot of our work, the y-intercept is equal to the c value. So whatever this guy is right there, there's your y-intercept. So if we have f of x is equal to 2x squared plus 7x plus 12, bam! The y-intercept is equal to 12. So at least we know that up here at 12, the parabola is going to go right through it somehow. We don't know anything else, but at least we know that's going to be the case. Otherwise, in a table of values, if you have xy, if you see an x value of 0, and you see a y value of some number a, well, we'll call it, we'll just put number there. Whatever that number is, that's your x-intercept. So if you see it like that, you go ahead and do that. If you're in the graph and you see this, you can actually use the functions of the graph to find the y-intercept in that case. But if you're in standard form, and the only form that you'll be able to use to find y-intercept is standard form, c is your value, and you're in good shape at that point. All right. Question number 2. What are the forms of the equations? And I'll give you information based on the different forms. First one is the standard form. Every equation, every function has a standard form. For quadratic, it's f of x is equal to ax squared plus bx plus c. Now, you can find all sorts of things here. Your vertex will be, that's a division sign, we don't want that, is going to be at the point negative b over 2a, comma, f evaluated at negative b over 2a. Whatever you get for this value, if it's like a 3, you just plug it in for x and go from there. Your line of symmetry. X is equal to negative b over 2a. Because the line of symmetry goes right through the vertex. Your y-intercept. That's equal to c. You can find your zeros. You can do that by factoring, which we'll cover in a different quadratic fact. You can do this using your calculator. Or, in an xy table, as soon as you see 0 for y, you're going to get a number here, and you get another 0. Say that's number 1, and that's number 2. Those are your zeros. Your y value has to be zeros in that case. So that's a lot of the really good information that you get from a standard form. Also, your a value. If a is positive, you have a parabola that opens up. If a is negative, you have a parabola that opens down. Now you have vertex form, which we can go from standard form to vertex form by what we call completing the square. And we are going to talk more about completing the square a little bit later. Vertex form, f of x is equal to a times x minus h squared plus k. Your vertex is at hk. A is still going to tell you if it's positive, it's opening up. If a is negative, it's opening down. And honestly, that's pretty much all you get from here. You can do table values, you can do other stuff, but that's the information we get from this function, from this form. It's not the best form on the planet to work with, but hey, it is a form. And now there's factored form. You get f of x is equal to a times x minus p times x minus q, where p and q are zeros. So that's the first thing you do. Second, your a, still, if it's positive, it's opening up. If it's negative, it's opening down. To get your vertex, what you're going to do is p plus q divided by 2, and what this is going to be equal to the x coordinate, because it's smack dab in the middle of the zeros. And then what you'll do is you'll take your function and then you'll plug in your x coordinate value. And then you simplify it at that point. So, for example, if you got p plus q over 2 to be equal to 4, and you had the function f of x is equal to 2 times x, let's go minus 3, and so that's 4, that's 8, x plus 8, 9, that's x plus 9, so that'll give me a distance of, that's I need 4, I just need a distance of 8. We'll put a 5, x plus 5 there. Sorry about this. That gives you your total length, and that'll tell you the length between zeros. So that basically says between here and here, you get a distance of 4. So what you can do is, if that's a positive 3 and that's a negative 5, well, that distance is 8. That's not going to really do anything. Let's change that to 8. Let's change that to 8. Now, what's the distance from 5 to this point and from this point to this point? Well, the distance has to be 4 and 4, so I know this is going to go to negative 1, so my x value is equal to negative 1. So what I'll do is I'll say f of negative 1 is equal to 2 times negative 1 minus 3, negative 1 plus 5. So I'll get 2 times negative 4 times 4, which is, I have a positive, positive, answer's negative. That's 16, that's 32, so that's negative 32. So I know I'm at negative 1 comma 32. Negative 32. And since my a is positive, I know I'm opening up, so I'm going to have a point here at negative 1 comma negative 32, and it's going to go up there, and it's going to go up through there. You got to be careful when you're doing stuff like this. Now, another way that you can think about it is, you can find, for example, f of x is equal to, let's say, x plus 2 times x minus 3. From here, we know x is equal to negative 2, and x is equal to 3. So, on our number line, I know I'm going to be at 3, I know I'm going to be at negative 2, and if I take b minus, if that's my a value, that's my b value, if I go b minus a, 3 minus a negative 2, and then divide that by 2, that's 5 over 2, which is 2.5. That's going to tell me how far over I need to go in each case. So this is going to be at 0.5. Because I go over 2.5, I go over there 2.5. So my x is at 0.5. So now I just do f of 0.5 is equal to 0.5 plus 2, 0.5 minus 3. So I get 2.5 times negative 2.5, which is 6.25. negative 6.25, so that'll get you your value as well. This is a lot more difficult to find your x-coordinate. At this point, remember always, calculator works. This point, remember, calculator works. This point, remember, calculator works. Alright, so that's question 2. Question 3. When do we have a maximum value or a minimum value? Alright, everything comes from whether it opens up, and that's a is greater than 0, or it opens down, which means a is less than 0, which means it's negative, that means it's positive. The vertex is going to be give us the x-coordinate, and then, since that's the smallest value, this is going to be the x-coordinate comma the minimum value. The y value in any function, the y is the value of the function. So I'll put that over here. The y value is the value of the function. Because a function is usually kind of telling us what's going on. It might be a distance formula, or it might be profit, or anything. Whatever you get as your answer is your y answer. That's going to be the one that tells us what the value actually is. So even though we have an x-coordinate, we know where it's going to be. The actual value for y is what is going to be the minimum value. And since that's the smallest value on the parabola, we get a minimum value. Up here, we get our x-coordinate, but we also have a maximum value. So you get your maximum value from a parabola opening down, and you get a minimum value from your parabola opening up. And last but certainly not least, let me grab another sheet of paper here for question number 4. Question number 4, I'll just do this right up here. What is a 0? Simply put, a 0 is an x-intercept. But it's also called a root. And it comes from the idea that if this x value, let's say that's 4. This is 4, 0. The 0 here is the value of the function. And a 0 is the 0 asks us, where is the function equal to 0? And that's going to be here, and that's going to be here. So in this case, we have 2 zeros. Unfortunately, that's not always the case. If you have a parabola whose vertex is on the x-axis, there's 1 0. And we call this a double root. So when we write this, say this is at -3. I could say f of x is equal to x plus 3, because it's always, we take the opposite of what we have, and x plus 3. There's where our double root comes from. Or you could just write it as f of x is equal to x plus 3 squared. And that squared indicates there's a double root. So when we just end up touching the x-axis at one point, we get a root. There's your 0. it's a double root. Here, it's just a single root. The second root pops up over here. And last but not least, if we have a parabola and all of a sudden it doesn't even intersect, no intersection, no real root / 0 / x-intercept. And that happens all the time. Eventually, like in Algebra 2, we'll get into the fact that there are two roots, but they're what we call imaginary. Alright, so that's fact 2. And we covered the y-intercept, forms of the equations, which is what we did right here. How do we know if we have a maximum or a minimum? And then last but certainly not least, what is a zero? We'll talk about calculating zeros later.